Okay, on this second part for 1.3, we're going to take a look at what is called piecewise defined functions. Okay, what's in red here, make sure you take this down. This is where you have a function that is made up of two or more equations, but each of the equations are over a specified domain. So there's a restricted domain for each of these equations. Okay, and we're going to take a look at one example. We're just going to do number one. Now, number one, this entire thing kind of looks a little confusing, looks a little overwhelming, but when you break it down literally to its pieces or its equations, it's actually very, very simple. There's two equations that make this up, this x squared plus 1 and this x minus 1. Now, when you plug in values for x, you only plug in values for x that are less than 0 for the first equation, and the opposite, you only plug in values for x that are greater than or equal to 0 for the second equation. So in short, it basically means is if x is a negative, you plug it in the first equation. If x is 0 or positive, you plug it in the second equation. So if they're telling you, hey, find f of 1, well, this 1, this is the x, and 1 is defined on this, the second equation. So I'm only plugging that in, this x minus 1. So when I plug that in, f of 1 just equals 1 minus 1, which is 0, and that's our answer. Very simple, once you know where to plug it in. Okay, this negative 1, it's negative. Well, this I'm plugging into x for the first equation, because this domain, x is less than 0, only takes negatives. So when I plug this in, I have negative 1, I put that in parentheses and square it, and then this is plus 1 right here, so I have plus 1. Okay, negative 1 quantity squared is positive 1, and then 1 plus 1 is 2. And that's our answer. Okay, 0. This is called the boundary point. Whenever we do piecewise functions, these values right there with the inequalities, they're always going to be the same. So the boundary point, sometimes students get confused and they say they plug it into both, but it's the only one where it equals 0, which is the second one, because it's underlined as x is greater than or equal to 0. So I just plugged it in the second one, so I plug it in, so instead of x minus 1 becomes 0 minus 1, 0 minus 1 is negative 1, and that's it. That's our answer. Alright, so it's actually a pretty easy concept. You basically just have to take whatever values for x, and you just have to ask yourself, alright, am I plugging into the first equation, or am I plugging into the second equation? And in order to know which equation you're plugging in, you have to look at the domain that's restricted for each of the two equations.